All right, today what we're going to talk about is factoring by difference of two squares and also grouping. So first let's talk about factoring by difference of squares. So first we always look to see if there's a GCF. So that's always the first step whenever you're factoring. And if there is one, factor out the GCF first. Then, after you've factored out a GCF, provided there's one, ask yourself if the given expression is a difference of two squares. So, a couple things that it needs to have. It needs to have two terms, there needs to be subtraction in between, and both terms are perfect squares. So what you do is you write two parentheses, and you take the square root of each term, and then put a plus in one and a minus in the other. So the example we have here is this is a perfect square because it's an even exponent, and that's a perfect square because it's an even exponent, and then we have a minus sign in the middle. So what we're going to do is we make our two sets of brackets, and we take the square root of the first. Well, the square root of a squared is a, so we're going to write a as a first term. Then we're going to take the square root of the second term, so the square root of b squared is b, and you're going to write b in each set of parentheses. Now, 1, and it doesn't matter which one's plus and which one's minus, but one needs to be plus, the other needs to be minus. So you must have opposite signs. So that's important when you're doing your difference of squares. All right, and then that's your final answer. That's how you do it. Now, I do want to point out, and we'll talk about this a little bit later too, but notice this is a perfect square, that's a perfect square, but this is not a difference of squares because you have an addition side. So you cannot do the difference of squares if there's a plus sign in the middle. It must be a subtraction sign. So let's get started. So what we're going to do is quick check, do we have a GCF? No GCF, so we're going to move on. So now let's look here. That is a difference. All right, so we've got our minus sign in the middle. Now we're going to take the square root of x squared, which gives you x. So we put in our two sets of parentheses there. I got x here as your first term. And then we're going to take the square root of 25, which is 5. That's going to be the second term in your parentheses. And now you're going to do opposite signs. So one needs to be a plus, the other needs to be a minus. You could do x minus 5, x plus 5, but either way, you need to have one sign is a plus, the other is a minus. All right, so what I want you to do is I want you to try this one. And then now let's go on to this one. Now, this one's a little different, okay? Before, there's no GCF, so we can go ahead and get started. So notice we have a 9 here, and we have an x squared. Well, if you're to take the square root of 9, you get 3. And then the square root of x squared is x. So if you're to do it all together, it would be 3x. So you put 3x as your first term, and then remember, the square root of 1 is 1. So we got a 1 here, and it is a difference of squares, so you need to have opposite signs. And there you go, that's your answer. So I want you to go ahead, I want you to try this one. All right, now let's look here. So now we do have a GCF. So we can factor, since they're both even, we can factor out a 2. So now that we factored out a 2, we're only going to look at what's inside here. We're still going to write the 2 down, but we're going to look at what's inside here. So this is a perfect square, this is a perfect square, and you have a minus in the middle. So you can do difference of squares. So again, bring that original GCF down, and from here we're going to break this into those two parentheses. So square root of x squared is x. Square root of 16 is 4. Make sure you have opposite signs. And then this is your final answer. So remember, GCF first, always look, and then you can go ahead and try difference of squares. So go ahead and do that one. And then now let's look here. So first off, I know these are both divisible by 5, so I'm going to factor out the GCF, which is 5. And once we divide both of these by 5, I'm left with 25m to the 4th and minus 4n to the 4th. So now, notice, this is even, and this is even. So since these are even, we can take the square root of them. So we're going to take the square root of 25m to the 4th, which is 5m squared. And then we're going to take the square root of 4n to the 4th, which is 2n squared. And then remember, opposite signs, and don't forget to bring that GCF down. All right, go ahead. I want you to try this one. And then as I showed you before, right now, these are perfect squares. That's a perfect square, but we can't do it because there's a plus sign in the middle. So this is not a difference of squares. And there's no GCF, so since we can't factor it, your answer is prime. All right, I want you to go ahead and try this. I will give you a hint. You can factor this. Do your GCF first. And then continue to go from there. But you cannot do difference of squares because you have a plus sign. All right. Now, when a GCF is a binomial, you can undistribute the binomial to factor. So, now we're going to look at what they have in common. So I'm going to erase this real quick just to show you what we started. So for this, we're going to look at what they have in common. So they both have a y plus 3. So we can actually do a GCF of y plus 3. So when you do that, we're going to divide, oops. There we go. We're going to divide, and you can put it in parentheses or not, both terms by y plus 3. And remember, that's going to be your GCF. So now that we've divided that, those cancel out, and I'm only left with x. And then those cancel out, and I'm left with the plus 2. So we're just taking this as one term, and then these two as your other term. So go ahead, try this one. And then for this one, same thing. They both have x plus 4 in common. So I'm going to factor out x plus 4. And that's going to be one factor. Well, once I factor that out, this cancels. I'm left with a y. And then this cancels, and I'm left with negative 5. So this would be what your GCF is, and this would be the leftovers. All right, go ahead and try that. And then now we're going to get to factoring by grouping. So you need to have 4 terms. If there's a GCF of those 4 terms, go ahead, take the GCF out. Then we're going to group the first 2 terms together, and then you're going to group the last 2 terms together. And then we're going to kind of hide, we're only going to focus on part of it, and we're going to do the GCF from each of the 2 groups. And then if we do this correctly, what's inside the parentheses should be exact match, and that's going to be your common factor. And then anything left over will be in the other parenthesis. All right, so now we have our 4 terms. So we're going to group it here, or you could do like this, that's fine, either way works. So what we're going to do is I'm just going to look at these. And when I look at the green section, I notice they both have at least an x squared in common. So I'm going to factor out an x squared. So this would be the GCF of this part. So after I factored out an x squared, I'm dividing each term by x squared. And when I do that, I'm left with x to the first power. and then I'm left with -5. So this is 1 times that. Now I'm going to come over here and I'm going to look at this. Well, in this term, the GCF is 3. So I'm going to divide each term by 3, and that's the GCF of the pink section. And when I divide this by 3, I'm left with x. And when I divide this by 3, I'm left with -5. And this is what your parentheses should go around. So again, GCF leftover, GCF, and leftover. All right. Now what we're going to do is we're going to take whatever your GCFs and we're going to put them together to make one set of parentheses. Now, if you do this correctly with grouping, whatever is inside your parentheses here should be the same. And that's just going to make one set. So we're going to put both those together to just make this. Now, your final, we can't simplify it anymore. That's your final answer. So I want you to go ahead. I want you to try that. So remember, you're going to group this together and then you're going to group this together. So go ahead, try that. All right, now that we've got some extra steps here. So we're going to look at this and we're going to group them together. And when I group this first section together, I notice that the biggest number they have in common, oh wait, look, all of these have a GCF of 2. So I'm going to go through and I'm going to divide each term by 2. And then whatever is left over goes in here. So now that I factored out your 2, now I'm just going to look at this part. And now I'm going to group this. And then I'm going to group this. So truthfully, you could have done it from here. You'll just have bigger numbers. So that's why we try to factor out the GCF. So now let's look. If I look here, I know the biggest I can take out would be 3x squared. So I'm going to divide this by 3x squared, and I'm going to get 4x. I'm going to divide this by 3x squared, and I'm going to get -1. So that's the first part. And now I'm going to look here. Well, there aren't any numbers, oops, that I could factor out. So if there's no GCF, put a +1. So with grouping, you always need to factor something out. So we're going to factor out a +1. And then if you divide each of these by 1, this is what's left over. Now, if you notice, what's inside the parentheses should be the same. So we're going to take what's outside and make it one set. We're going to take what was inside and make it another set. And then, of course, don't forget to bring down your GCF. And then we can't simplify these anymore. So this is your final answer. So like I said, don't forget to bring down your GCF. That is a common mistake. And if you can't factor out anything, put a +1 outside the parentheses, just like we did there. All right, go ahead. I want you to try that one. So remember grouping GCF first with your 4 terms, and then you're going to start grouping 2 terms together and group the other 2 together and factor it out. And that is your factor by difference of 2 squares and grouping.